mathematics made easy. Okay, so in our previous video, that was yesterday, we solved some problems and integration. We solved 20 integral questions yesterday. So in today's video, we are solving, mainly we are dealing with differentiation. So we are taking it from the scratch. Do you understand? So if you are a secondary school student, okay, a college student, a student of grade 10, grade 11, grade 12, so this is for you. And then you are in 100 level, 200 level, 300 level in the university. Okay, so this topic is for you. All right. So calculus. So differentiation. All right. So please, as you're watching, don't forget to like, comment, share, and also subscribe. Right? Don't forget to subscribe to the channel. Okay. Now, when you're talking about differentiation, so I'm gonna start with differentiation from the first principle. Do you understand? So how you can differentiate some functions from the first principle, right? And then here is the formula for the differentiation. So given a function f of x, okay? And then we want to find the derivative of f of x. So you can see it this way. In some textbooks, you write f prime of x, okay? In some textbook, you see the y over the x. In some textbook, you are going to see change in y over change in x. So anyhow you want to write it, all right? So I will be using, and then some. If they use y is equal to, you can use y prime. You understand? But I will be using f prime of x. So since I'm using f of x for the function, okay? So given a function f of x, and then you want to find the derivative. So f prime of x will be equal to limits of change tends to, h tends to infinity, then of f of x plus h minus f of x, then everything over h, all right? So that is the formula you use to differentiate function from the first principle. I hope we are getting it. All right, I'm gonna do some examples. That is, we're gonna differentiate some functions using the first principle. Okay guys, so let's do that. Now, example one. So we have a function f of x equals x. So find f prime of x. You have to what? To differentiate x. You have to find the derivative. Okay? You have to find f prime of x. It means find the derivative of x. Now, how do you find the derivative of x? Since you are given a formula already, so that is, we said f prime of x equals limit of h tends to infinity of f of x plus h minus f of x, then everything over h. So first you are going to do now is to find f of x plus h. So what is f of x plus h? How did you find it? How do you find f of x plus h? Alright guys, if you want to find f of x plus h, so you come to this, your f of x. Alright, so f of x plus h means you are adding h to your what? To your x. So f of x plus h will be equal to what? X plus h. I hope you are getting it. So f of x plus h will be what? X plus h. So then what will now be our f prime of x? So you come back here, you substitute f of x plus h to be x plus h. And then you substitute f of x to be what? To be x. Alright? So we're going to have f prime of x equals limit of h tends to infinity. Then f of x plus h is what? X plus h. Then minus f of x, which is what? X. Then everything over h. The next thing is to remove this bracket right here. So this is equal to limit of h tends to infinity of x plus h minus x over h. So x minus x will give us 0. So this will be equal to limit of h tends to infinity of h over h. So h divided by h will give us 1. So we have limits of h tends to infinity of 1. And then according to the rule of limit function or function, we take the limit of, let me just say, h tends to a of a constant. So that's going to give you what? The constant. Take note of that. So we take the limit of 1 as h tends to infinity. So that is going to give us what? 1. So that shows that if you differentiate x, that is, if you find the derivative of x, you are going to get what? You are going to get 1. Alright? So that's how you differentiate from the first principle. I hope we are getting it. Okay, guys, now let's do another example. Differentiating from the first principle. So that is the first thing we are. If you are new to this channel, please don't forget to subscribe, you like, comment, and also share to your guys with your friends. Okay. Now, example 2, we have if f of x equals x raised to the power of 2, then find f prime of x. That is, we are asked to differentiate x raised to the power of 2. Find the derivative. Okay, you make use of your formula, all right? And don't forget, so the first thing you're going to find is f of x plus h. Now let's do that. So f of x plus h will be equal to what? It means you come back to the function given to you, and you add h to what? X. So that means you're going to have x plus h. Then you can say the second power. So raised to the power of 2. Okay? So f of x plus h equals x plus h to the second power. Then what are you going to do next? What you have to do is to expand this expression. Alright? So how do you expand? X plus h to the second power, it means x plus h, then multiplied by x plus h. I hope we are getting it. Then you open the bracket. So you use x to open everything here, then you also use h to open it. This is what I'm saying. You use x, you're going to have x into bracket, x plus h, then use h plus h into bracket, x plus h. So x multiplied by x equals x to the second power, x multiplied by h will give us xh, plus h multiplied by x, xh, plus h multiplied by h, h to the second power. Okay? Then xh plus xh will give us what? 2xh. So we have f of x plus h equals x to the second power plus, we have 2xh, then plus h to the second power. So since we now have f of x plus h, so we can now find our derivative. I hope we are getting it. So f prime of x will be equal to limits of h tends to infinity. So f of x plus h is now what? X squared plus 2xh plus h to the second power. Then minus f of x, and our f of x is what? X to the second power. So minus x to the second power, then everything over h. So x squared minus x squared are going to give us what? 0. So what is the limit of h tends to infinity, then 2xh plus h to the second power plus h to the second power, then everything over h. Now, what do you notice here? We can see that h is common in the numerator, so we can factor out h. So we're going to have limits of h tends to infinity of h into bracket 2x plus h, then everything over h. So definitely h, we cancel out h. Then, anyway, you see h there, so we're going to substitute what? H to what? Infinity. So then this will now be equal to 2x, right? When you substitute h there, so we have 2x. Alright, so that is how you differentiate this kind of what? This kind of function using the first principle. So you can make use of, you can let f of x be equal to x cubed, x raised to the power of any one you like. You still get it. But if you don't want to use this formula, that is another way around. You can differentiate function. You understand? Some function using the first principle. You see, there's also first principle, okay? There's also called first principle. Now, look at it. I'm going to use the first example and the second example. we have f of x equals x. Alright, this is the first example I did. So using this method, so I can just call this, let me call this y. We have y is equal to x, and I want to find the derivative using the first principle. So in case you don't remember the formula, so you can actually do it this way, okay? So you had increase in y to the y by, what do we call the increase? It means change in y, alright? So you use delta y to represent it, change in y. So you had delta y to this y part, that is your left hand side, and you had increase in x, that is delta x to the what? To the right hand side. Okay? So if you do that, you're gonna have y plus change in y equals x plus change in x. Okay? Now, next thing you are going to do is that you remember y is x. Y is what? Y is x. So you substitute y back to the what? To the x. Then if you do that, we're going to have x plus change in y equals x plus change in x. So next thing you are going to do now is to subtract x from both sides. So we subtract x from both sides, we're going to have x plus change in y minus x equals x plus change in x minus x. So x minus x will give us what? 0. So what we have now is change in y equals, then x minus x also what? 0. What you have now is here what? Change in x. Then you divide through by change in x over change in x. So what you have now is what? Change in y over change in x is equal to what? Is equal to 1. You can see it's very beautiful. Alright? So that is how you differentiate from the first principle. Okay? So, that's about that. Let's do another example. That's another example. The second example I did. So, y equals x to the second power. Okay? Using the same method right here. So, let's do that. Let's find the derivative. Let's find the derivative. So, what you're going to do now is what? You had increase in y to the y part. At least we're going to have y plus change in y. Then you had increase in x to the x part. This x plus increase in x then to the second power. Alright? So you open this bracket. So you open this bracket. So we're going to have y plus change in y equals x plus change in x multiplied by x plus change in x. So we have y plus change in y equals, x to the second power, x change in x change in x, then change in x to the second power. So we have y plus change in y equals x to the second power plus 2x change in x plus change in x to the second power. Now remember, y is x to the second power. So substitute y back to the what? X to the second power. So we have x to the second power plus change in y equals x to the second power plus 2x change in x plus change in x to the second power. Then we subtract x to the second power from both sides. So we do that, we have change in y equals 2x change in x plus change in x to the second power. Now, what do you notice in your right hand side? On your right hand side, change in x is common, so you can factor out change in x on your right hand side. So we do that, we have change in y equals change in x into bracket 2x plus change in x. That is, if you factor out change in x. Okay, so what will remain here is 2x, and what's going to remain here is change in x. You understand? The next thing you're going to do is to divide through by change in x over change in x. So change in x, we cancel out change in x. So what we have now is change in y over change in x equals 2x plus change in x. Then you take the limits of change in x tends to what? 0. Alright? So we take the limit of change in x tends to 0. So what we have now is what? Change in y over change in x equals 2x plus 0. That's going to give us 2x. That is beautiful and cool. That's beautiful and cool. So that is how you do that using this method. I hope we are getting it. Alright. Okay, you asked that why is it not to the second power anymore? Yeah, this is it. It's raised to the power of 2. Alright, then we added increase in x to the both sides. Are you with me? Then we expanded this. I remember that y is x to the second power. You substitute y back to x to the second power. You get? So then we have x squared plus change in y. When you expand this, we have x plus change in x to the second power. Then subtract x to the second power from both sides. You got what I'm saying now? So what we have now is change in y, which is now 2x change in x plus change in x to the second power. Then you factor out change in x. So when you factor out change in x, what you're going to have now will be change in x into 2x plus change in x. Then you divide through by that change in x. Alright? Then we have change in y by change in x equals 2x plus change in x. Then take the limit of change in x tends to 0. Then we do that, we have the final answer. I hope you understand what I'm saying now. Okay, let's do one example. Let's do one example on that. So that you can get it very well before we move to the next method of differentiation. Okay, when you have y equals x to the third power, look at this. Y equals x to the third power. Using the first principle, how are you going to find the derivative of this? Okay? You're going to do the same thing that we'll be doing. You have increase in y to the y part, okay? So we have y plus increase in y. Then you have increase in x to the x part. You know what I'm saying now? So this will be x plus increase in x. But don't forget, this to the third power. Then you raise to the third power. How we get it? Then we expand x plus increase in x to the third power. I don't know. You should be able to expand this. You know, if you expand this, we expand x plus increase in x to the third power. You should get x to the third power plus 3x to the second power increase in x plus 3x increase in x to the second power plus increase in x to the third power. If you're wondering how to get this, yeah, it's very easy though, very easy. I know this since when I was in senior secondary school. I've memorized all this stuff. I'm going to teach you how to expand that, alright, without you stressing yourself too much. Now we call something Pascal triangle. Pascal triangle. You know, here's your Pascal triangle. That's the coefficient of your binomial expansion with that. So this will be 1. How do we get this one? This is when you have x plus y raised to the power of 0, you have 1. Okay? Then when you have x plus y raised to the power of 1, the coefficient of x is 1, coefficient of y is 1, alright? Then when you have to the second power, okay, you are going to have x squared plus 2xy plus y squared. Coefficient of x is 1, 2, 1, you know. Coefficient of xy is 2, coefficient of y squared is 1, alright? That's how you get it. So I'm going to write out the Pascal triangle. The Pascal triangle is 1, 1, 1, 1, 2, 1, and it's the pattern. 1 plus 2, 3, 2 plus 1, 3, then write 1, okay? 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, you write 1. Okay, that's the pattern. 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, then you have 1. That's the pattern, alright? So you'll be wondering, which one are we using there? Which one are we using over there? So this is what we are using. We are using this guy. Because this is the third power. Don't forget, to the 0th power, to the 1st power, to the 2nd power, to the 3rd power. Okay? And the one we are using here is the 3rd power. So these are the coefficients we're going to be using to the 3rd power. 1, 3, 3, 1. So x plus increase in x to the 3rd power will be equal to x to the 3rd power. Now, this x will be decreasing while your change in x will be increasing, alright? So you have x to the 3rd power, then change in x raised to the power of 0. Plus, don't forget I say x will be decreasing. So this will be x to the 2nd power, then your change in x will be what? Increasing. Change in x to the 1st power. Plus x to the 1st power, then change in x to the what? 2nd power, alright? Plus x to the 0th power, then plus change in x to the what? 3rd power, alright? So this will be equal to x cubed, you know, changing x to the 0th power is 1. Anything raised to the power of 0 except 0, they give you what? 1. Then changing x to the 1th power, that's changing x. So we have x squared changing x plus x changing x to the 2nd power then plus change in x to the third power. Alright. So we now take the coefficient. Coefficient of to the third power is 1. X squared change in x 3. X change in x squared, you can see 3. And last one, which is what? 1. I hope we are getting it. So if we expand x plus increase in x to the third power, so that's going to give you x cubed plus 3x squared change in x plus 3x change in x squared plus change in x to the third power. All right. So you have to memorize your Pascal triangle very well to be able to expand more, larger version like this. Okay? So your Pascal triangles are the coefficients of your binomial expansion. Do you understand what I'm saying now? Okay. Now, since we already know what our x plus increase in x to the third power is, so we have y plus change in y equals x to the third power, alright, plus 3x to the second power multiplied by increase in x, plus 3x multiplied by increase in x to the second power, plus increase in x to the third power. That is what we got the other time. Okay. So what are you going to do next? Y is x to the third power. So then substitute y back to what? X to the third power. So we do that, we have x to the third power plus increase in y equals x to the third power plus 3x to the second power multiplied by increase in x plus 3x multiplied by increase in x to the second power plus increase in x to the third power. Are we getting it? So the next thing we are going to do is to subtract x to the second power both sides. Are you with me, guys? So if you subtract x cubed from both sides, what are we going to have? So we're going to have change in y equals 3x squared into bracket change in x plus 3x into bracket change in x to the second power plus change in x to the third power. So as we usually do that, you can see we can factor out increase in x on your right hand side. So we have increase in y equals increase in x into bracket 3x to the second power plus 3x multiplied by increase in x plus increase in x to the second power. That is if you factor out increase in x. So what are you going to do next is to divide through by increase in x over increase in x. So increase in x will cancel out increase in x. So we have increase in y over increase in x is equal to 3x to the second power plus 3x into bracket increase in x plus increase in x to the second power. Alright, so let's say to take the limit of increase in x tends to 0. So we take the limit of increase in x tends to 0, that is, anywhere you see increase in x just put 0. So 3x times 0, that is 0. Increase in x squared, that is 0 squared, that is 0. So what you have now is change in y over change in x equals 3x to the second power. I hope we are getting it. Okay? Please don't forget to subscribe. We are just you are new to the channel. Don't forget to subscribe. Comments what you don't understand, alright, so that we can go back to it, alright? Share. Okay. I hope we are getting it. Okay, I'm gonna slow down. Very sorry, I'm gonna slow down. Okay? I'm gonna slow down. Alright. Let's do another example. We see on the first principle, okay? We see on the first principle. Let's do another example. Now, let's do that of x raised to the power of 4. X to the fourth power. Let's do that. So when you have y equals x to the fourth power, how do we differentiate this? Same method we've been using since. Let's do that. You had increase in y to the y part. You had increase in x to the what? To the x part. Alright? Let's do that. We have y plus increase in y equals x plus increase in x to the third power. Okay? So next thing we are going to do is to expand. Sorry, this is to the fourth power. So next thing we're going to do now is to expand. Alright, we do what? We expand. So let's expand this. We have x plus increase in x to the fourth power. I said we're going to start with this first quantity, which is your x, then x to the fourth power, okay? Then changing x to the 0th power, plus. Don't forget, your x will be decreasing, while your changing x will be what? Increasing. Okay? So this will now turn to x to the 3rd power. While your increase in x will return to what? Raised to the power of 1. Plus your x will reduce to what? X to the 2nd power. While your increase in x will increase to what? To the 2nd power. Your x will decrease to what? X raised to the power 1. While your increase in x will increase to what? To the 3rd power. Then the last one, plus x raised to the power was 0. And then your increase in x will raise to what? The 4th power. I hope you are getting it. So this will now be equal to x raised to the power of 4. So change x raised to the power of 0, that is 1. No. Any number to the 0th power will give you 1. Except what? Except 0 raised to the power of 0. Okay? So 0 raised to the power of 0 is not 1. But any other number to the power of 0 will surely give us 1. Take note of that. So increase in x to the 0th power will give us 1. So 1 times x raised to the power of 4 will give us x raised to the power of 4. Then plus, now increase in x raised to the power of 1 is still increase in x. So we have x raised to the power of 3 multiplied by increase in x. Okay? So we have x squared multiplied by, increase in x to the 2nd power plus x raised to the power of 1 is still x. So we have x multiplied by increase in x raised to the power of 3. And the last one, x raised to the power of 0 is 1. Then 1 multiplied by increase in x raised to the power of 4 will give us increase in x raised to the power of 4. The next thing is the coefficient. How do you know your coefficient? Alright, from the Pascal triangle I gave you guys the other time, I said you have 1, 1, 1. This is when your expression is raised to the power of 0. When your expression is raised to the power of 1. Okay? Then when your expression is raised to the power 2, we have what? 1. You have 1 plus 1, 2, then you have 1. Okay? So when your expression is raised to the power 2. When your expression is raised to the power 3, we have 1. 1 plus 2, 3. 2 plus 1, 3, then you have 1. Okay? When your expression is raised to the power 4, we have 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. Then you have 1. This is when it's raised to the power 4. And then what you are dealing with is what? To this 4th power. So this is the coefficient we'll be using. So for x raised to the power 4, the coefficient is 1. For x cubed changing x, the coefficient is 4. For x squared changing x squared, the coefficient is 6. Okay, for x changing x cubed, the coefficient is 4. Then for changing x raised to the power 4, the coefficient is 1. I hope you understand very well. Okay, now since we've gotten the expansion, so we can now solve our problem successfully. Alright, so let's do that. So we have y plus increase in y equals, so x raised to the power of 4 plus 4x cubed changing x plus 6x raised to the power of 2 changing x raised to the power of 2 plus 4x changing x raised to the power of 3 then plus changing x raised to the power of 4. Alright, so what is the next thing we are going to do over there? Yeah. Good. So we know y is x raised to the power of 4. Alright? So we have x raised to the power of 4 plus increase in y equals x raised to the power of 4 plus 4x to the 3rd power multiplied by changing x plus this x squared into bracket changing x to the 2nd power plus 4x changing x to the 3rd power plus changing x to the 4th power. Then you subtract x raised to the power of 4 from both sides. So if we do that, we have increase in y equals 4x to the 3rd power changing x plus 6x to the 2nd power changing x to the 2nd power plus 4x into bracket changing x to the 3rd power plus changing x to the 4th power. Then you factor out changing x. So if you do that, you're going to have changing y equals changing x into bracket 4x to the 3rd power, okay, plus 6x to the 2nd power multiplied by increase in x plus 4x into bracket increase in x to the 2nd power, then plus increase in x to the 3rd power. Then what are we going to do next? We divide through by increase in x. So increase in x, we cancel out increase in x. So we are going to have increase in y over increase in x equals 4x cubed plus 6x squared into brackets increase in x plus 4x into brackets increase in x to the second power plus increase in x to the third power. Then now take the limit of increase in x tends to 0. So anywhere you see increase in x, you put what? You put 0. So put 0 here, you have 0. Put 0 here, you have 0. You put 0 here, you have 0. So what you have now is what? 4x to the third power. I hope we understand that very well. All right. So, good. Now, once you now have x to the nth power, that is what one of what is saying, the pattern we are following. So when x is raised to the nth power, so how do we differentiate that? Okay, when x is raised to the nth power. Please, if you're watching for this first time and you haven't subscribed, please make sure you do so. Subscribe to the channel, all right? You like the video, you comment, and you also share. Good. When you have y equals x raised to the power of n. So how do we differentiate this? Okay? Where your n is not equal to -1. Okay? Okay, sorry. Your n can be equal to -1. I'm very sorry for that. Your n can be equal to -1, okay? So how do we differentiate this function right here? You'll be thinking, how to differentiate this? This is raised power n. This is not raised power 0, it's not raised power 1, it's not raised power 2, it's not raised. So raised power n, n can be any number. You get what I'm saying? N can be any number. But in the case of integral, we have integral of x raised power n. N cannot be equal to negative, though n could be equal to -1. You know, this is equal to x raised power of n plus 1 over n plus 1. But if you have integral of x raised power of -1 dx, you cannot make use of this formula. That's what I'm saying. That's what I mean. Okay? You cannot make use of this formula. Why? Because integral of 1 over x is what? Natural log of x plus c. Okay? So when you're talking about integral, your n cannot be -1 right here. But it could be -2, it could be any number except -1. Because if you integrate x to the power of -1, you are going to get natural log of x. So take note of that. But in differentiation, it is different. Okay? It's different. Alright, now this is what you want to do. You make use of the method you've been doing since morning. Okay? You differentiate from the first principle. So you had increase in y to the right part. So we have y plus change in y. Then you had your increase in x to the what? To the x part. So we have x plus increase in x, then to the nth power, Then you'll be imagining, how are we going to expand x plus increase in x raised to the power of n? How do we do that? Now, this is where your word comes in. Your binomial expansion is very, very important right here. Your binomial expansion, right? So x plus increase in x raised to the power of n is equal to what? So your binomial expansion is very important. We have x raised to the power of n, then change in x raised to the power of 0, then n combination 0. What are we doing? Now, whatever that was here would what? Taking the power of your increase in x. So plus, this is x raised to the power of n, then we're going to have what? X raised to the power. Don't forget, I said your x will be decreasing. So if your x raised to the power of n decreases, you're going to have what? X raised to the power of n minus 1. Then your increase in x will be what? Increasing. So we have change in x raised to the power of 1. So this is what? N combination 1. Then plus dots. So plus x raised to the power of 0 multiplied by increase in x raised to the power of n. You have n combination n. Beautiful. Now, the meaning of this dots means that you still have some terms in between these guys. A lot of terms are there. Okay? So, reason I don't put everything, you cannot write everything down. You just have to shorten it. Do you understand? That's why I shorten it. Okay? So, what are we going to do next? So, we're going to have x raised to the power of n. So, increase in x raised to the power of 0. That will give us 1. Take note of that. Then we have n combination 0 plus x raised to the power of n minus 1. Then multiply by what? Increase in x. Then multiply by what? N combination 1. then plus dot dot plus this guy, x raised to the power of 0 will give us 1. Then plus increase in x raised to the power of n combination n. I hope we are getting it, guys. I hope we are getting it, guys. Good. So the next thing you are going to do is to find these coefficients. These coefficients. You have n combination 0, you have n combination 1, you have n combination n. How do you find those coefficients? That is the next thing we want to do now. Okay, now let's do that. Let's start with this guy. Remember, n combination p is equal to n factorial over p factorial multiplied by n minus p factorial. Take note of that. Okay? Your combination n combination p, it means what? N factorial over p factorial minus p factorial. Take note of that. Take note of that. So n combination 0, it means what? N factorial over this 0 factorial, then into bracket what? N minus 0 factorial. So this will be equal to n factorial over, 0 factorial is what? 1. So we have 1 multiplied by n minus 0 is n. So we have n factorial. So n factorial we cancel out n factorial. So we have 1 over 1, which is equal to what? 1. So that shows that n combination 0 is 1. So n combination 0 is 1. Let's write it this way. Now next thing is to find n combination 1. So n combination 1 will be equal to what? Let's do that now. So this will be equal to n factorial over what? 1 factorial into bracket n minus 1 factorial. So which means n factorial over n minus 1 factorial. Then you'll be wondering, how are we going to simplify this? Yeah, we can simplify that. Now, from your factorial, n factorial means n multiplied by n minus 1, n minus 2, n minus 3, times 3, times 2, times 1. That is your n factorial. Good. So we can rewrite n factorial in terms of this our denominator so that it can cancel out. What am I saying? It means n factorial means n into brackets n minus 1 factorial. Okay? So like everything right here is equal to n minus 1 factorial. Are we together now? So we cannot rewrite these guys. So instead of us writing factorial, we can write n into brackets n minus 1 factorial, then over n minus 1 factorial. Are you getting it, guys? So what's the next thing? N minus 1 factorial, we cancel out n minus 1 factorial. So that shows that n combination 1 is equal to what? N. So let's write out n right here. And the last one, we have n combination n. N combination n. So how do we do that also? So n combination n, that was n factorial over n factorial into bracket what? N minus n factorial. So this will be n factorial, n factorial we cancel n factorial. So we have 1 over n minus n is 0. So 0 factorial is 1. We have 1 over 1, which is equal to 1. So that shows that n combination n is 1. So since we've gotten our coefficients, so we have s raised to the power of n combination 0 is 1, plus s raised to the power of n minus 1, increase in x, okay, then multiplied by what? N, n combination 1 is n, plus plus change in x raised to the power of n combination n is what? 1. That's cool. So we now have this guy, where is it? Y plus change in y is equal to this. Remember that y is what? X raised to the power of n. Okay, so we are going to have x raised to the power of n plus increase in y equals x raised to the power of n plus x raised to the power of n minus 1 multiplied by increase in x multiplied by n plus plus increase in x raised to the power of n. Next thing is to subtract x raised to the power of n from both sides. So we do that, we have increase in y equals x raised to the power of n minus 1 multiplied by increase in x multiplied by n plus increase in x raised to the power of n. Now, as usual, the next thing you're going to do now is to factor out increase in x. So we factor out increase in x, you are going to have increase in y equals x raised to the power of n minus 1. Sorry, increase in x into brackets. I can bring out this my hand here, so you have n multiplied by x raised to the power of n minus 1 plus plus Now, if I factor out increase in x from increase in x raised to the power of n, what's going to remain? For instance, you have 2 raised to the power of 3. And then if I factor out 2 from here, what am I going to have? I'm going to have 2 into brackets, 2 raised to the power 3 minus 1. Yes, I've removed 1 to the, and 3 minus 1 is what? 2. So that will be 2 into bracket 2 squared. So that's what we are going to do here also. If I remove 1 increase in x here, what's going to remain? Increase in x raised to the power n minus 1. I hope we are getting it, guys. The next thing is to divide through by increase in x over increase in x. So increase in x, we cancel out increase in x. So what you have now is what? Increase in y over increase in x is equal to n multiplied by x raised to the power of n minus 1 plus dot 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 plus increase in x raised to the power of n minus 1. Then take the limit of increase in x tends to what? 0. So all they will become 0. They will become 0 because there still was increase in x there. So what remained was n multiplied by x raised to the power of n minus 1. So therefore, if you have x raised to the power of n, then the increase in x will be equal to what? N multiplied by x raised to the power of n minus 1. That's the pattern. Alright, that's the formula we will be following. Okay, so you can use this to find the derivative of the kind of function we find in this sense. You can start with y equal to x. This is raised to the power of 1. Use input n to be 1. We have 1 multiplied by x raised to the power of 1 minus 1. 1 minus 1 is 0. So we have 1 times x raised to the power of 0, and x raised to the power of 0 will give us 1. So we have 1. We differentiate x, we have 1. Using that formula. I hope we are getting it. So you'll be wondering how we get the formula. So this is how you find the formula. That's how you show it. Do you understand? So that's how you show it. Okay. I hope we are getting it, guys. I hope we are getting it, guys. Okay. Now, let's try and differentiate polynomial functions. Alright? A polynomial. So let's try and differentiate some polynomials. Now, given y equals, I hope we can see what is on the board very well. So we have y equals x raised to the power of 3 plus 2x raised to the power of 2 plus x plus 1. Then find the y dx, or change the y over change the x. So how do we find the derivative? You can give it a try. Let's see what you get. Give it a try. I will count 1 to 10, and let's see what it gets. Are you ready? Okay, let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. All right. So let's do it together. So we have y is equal to x cubed plus 2x squared plus x plus 1. So I want to find the derivative. You know, I already gave you guys the formula that we'll be using, the pattern we'll be using. Then if y equals x raised to the power of n, so the y over the x will be equal to what? N multiplied by x raised to the power of n minus 1. So that will be the pattern we'll be using. So increase in y over increase in x now be equal to what? Now right here, the value of n is 3. So we have 3 multiplied by x raised to the power of what? 3 minus 1. Plus the value of n here is 2. That will be 2 multiplied by the 2 here, then multiplied by x raised to the power 2 minus 1. Then plus the value of n here is what? 1. We have 1 multiplied by x raised to the power 1 minus 1. And remember, if you differentiate a constant, even if it is 1 million that is a 1 trillion, quadrillion, centillion, any constant, it is 0. So if we differentiate 1, we get 0. Since we can see terms of x there, though it is there, x raised to the power 0. That will be 0 times x raised to the power 0 minus 1. That's still going to give us 0. Okay? So that's why we just write 0 straightforward. I hope you are getting it, guys. Good. So this will be equal to 3x raised to the power what? 3 minus 1 will give us 2. Plus 2 times 2 will give us 4. Then x raised to the power 2 minus 1, that is 1. plus, 1 minus 1 is 0. And x raised above 0 will give us 1. And then 1 times 1 will give us what? 1. Alright, so that's the answer. So if we differentiate x cubed plus 2x squared plus x plus 1, so you are going to get 3x squared plus 4x plus 1. Do you understand, guys? I hope we are getting it. I hope we are getting it. All right. So don't forget to give us a like. All right. Don't forget to subscribe. Don't forget to don't forget to share. Good. Let's move on, guys. Another example. We have y equals. Let's think of another one. We have y equals 4 square roots of x plus cube roots of x plus nth roots of x. Look at this. Find the y over dx. Find the y over dx. So how do we differentiate this? How do we differentiate this? Let's do that together. So let me clean this. So this is what we are going to do. Yeah, according to law of indices, we can write square root of x in this form. Square root of x, or let me just say nth root of x means what? X raised to the power 1 by n. Okay? So square root of x means x raised to the power 1 over 2. Cube root of x, that's what? X raised to the power 1 over 3. Fourth root of x, that's what? X raised to the power 1 over 4. And so on and so forth like that. Do you understand? So that is what we're going to use here to solve this problem successfully. Alright, so this means that y equals 4 into bracket. So we can write square root of x as what? X raised to the power 1 over 2. Then plus cube root of x, that is what? X raised to the power 1 over 3. Plus nth root of x, that is what? X raised to the power 1 over n. You can see that is beautiful. So then we can now mix up your formula right here. We have y is equal to x raised to the power n. So the y gets to be what? N multiplied by x raised to the power n minus 1. So this will now be equal to 4 into bracket. We differentiate x raised to the power 1 over 2. So that 1 over 2 times x raised to the power 1 over 2 minus 1. Then plus, if we differentiate x raised to the power 1 over 3, that will be what? 1 over 3 multiplied by x raised to the power 1 over 3 minus 1. And the last one, if we differentiate x raised to the power 1 by n, that will be 1 over n multiplied by x raised to the power 1 by n minus 1. That's cool, is it? Very cool and beautiful. Okay, so this will be equal to 2 into 1, 2 in 4, that is 2. So we have 2 into bracket x raised to the power. Now what is 1 over minus 1? That is minus 1 over 2. Then plus, we can bring out this 1 over 3. So we have 1 over 3 into brackets x raised to the power. So 1 over 3 minus 1 is going to give us minus 2 over 3. Then plus, we can bring out this 1 over n. So we have 1 over n into brackets x raised to the power. So 1 over n minus 1 is what? 1 minus n. So that is cool. So that is the answer to our problem. Okay? So we differentiate 4 multiplied by square root of x plus cube root of x plus n root of x. So that's going to give you 2 into brackets x raised to the power minus 1 over 2. Plus 1 over 3 into bracket x raised to the power negative 2 over 3. Then plus 1 over n into bracket x raised to the power 1 minus n over n. Oh. Sorry. Kilili. Hello, can you see the board, please? Comment. Oh, it's green. I'm coming. I've touched something. Hey, yeah. I'm coming, please. I'm very sorry. I'm coming. I'm very, very sorry. I think I will have to end this live. Guys, I think I will have to end this, then I'll come back in some minutes times. I don't know what is wrong. Okay, I'm coming. I have to end it now.